Okay, so now can you tell me what were the labor demand and capital demand that we got when we solved the long run problem for this one? What was the long run conditional labor demand and long run conditional capital demand? L, C, W, R, Y. What was it? K, C, W, R, Y. What was it? I think it was this. Okay, so this was what we got. Now what I'm going to do is I'm going to solve this short run problem with respect to capital, and I'll show that I'll get exactly the same thing. Okay, because that's my objective, right? I want to minimize short run cost, which is WY squared by K plus RK with respect to capital. Okay, because that's the short run cost associated with this production function, right? So I'm going to minimize the short run cost with respect to capital and check that if I'm going to get this or not. Okay, can you do that? Tell me what is the solution to this optimization problem? It's just a one variable problem. How will you do this? You can take the derivative. Okay, so let's take the derivative. What are we going to get? Minus W y square. Okay, so K square, right? Plus R. Is that what we are going to get? Okay, now let's plot this derivative. Okay, so I'm not going to straight away set it equal to 0. I'm going to tell you why. I mean, what you should do here. Okay, I mean, whether you should set it equal to 0 or not, we'll figure it out. Okay, so it's a function of what? Capital. Okay, because that's what we are choosing, and y is given, w is given, r is given. Okay, so we are just going to see how this function looks. Okay, notice that as k goes to 0, this term gets bigger and bigger, so it's basically kind of approaching negative infinity, right? As k goes to 0. Do you all agree? Yes or no? Okay, and as k goes to infinity, what can you say about this term? As k goes to infinity, this term approaches, this whole term approaches r. Is that fine? Okay, so if I plot this, it's basically asymptotic to r. Okay, so if I plot this, what am I going to get? Well, is that okay? Yes or no? I'm plotting this. This is kind of marginal quantity. Okay, this is the derivative of this. Okay, I'm not calling it marginal cost because that's not the right word for this. Okay, it's like marginal of the objective with respect to choice variable. Okay, in this case the choice variable is capital. Okay, so this is how it looks, right? Okay, it's as k goes to 0, this term goes to negative infinity, and as k goes to infinity, this term becomes eventually positive and then becomes asymptotic to r. Do you all agree? Now you want to minimize cost, so initially this derivative is negative, so that means if you choose more capital, the cost goes down. Do you agree? If you choose more capital, the cost goes down because the derivative is negative. So higher amount of capital leads to lower cost because the derivative is negative. Yes or no? The derivative is negative. So what do you mean by negative? Negative means that this, your cost goes down by this much magnitude if you like increase the amount of capital from this point to this point. Okay, so where is the cost minimum? Cost is minimum at this point, because beyond this point your cost is going to go up, right? Because beyond this point the derivative becomes positive. So if the derivative becomes positive, you are going to add to your cost if you produce more, if you use more capital. Have you all understood this? Okay, so where is the cost minimum? Cost is minimum where this is equal to 0, where this quantity is equal to 0. That's something that we get from this graph. Okay, and this will give you exactly this solution. So just solve it and check that this is what you're going to get. So just take it to the other side and then just do the simple algebra and you will get this. Now if you want to get this, then you can substitute this solution, as I told you earlier, in the short run conditional labor demand function, and you should get that. Just do that now. Just substitute this in place of k and check what you're going to get. Are you all getting this? And that's exactly this. So I've already told you that it is not a surprise. Okay, it is something that was expected, because solving this problem is equivalent to solving this problem in 2 steps. Okay,